We are now looking at similar shapes. As with the previous video of congruency, the important part here is the corresponding. So basically, let us look at similar shapes. So the rules of similar shapes is that all corresponding angles are equal. All corresponding angles are equal. And all corresponding sides are in the same ratio, not equal as the congruency, but all corresponding sides are in the same ratio. So basically what this is trying to say, we are looking at this triangle and this triangle as they are, the first rule of similarity, as it is said here, all corresponding angles are equal and all corresponding sides are in the same ratio. So what this means is all corresponding angles are equal. Let us do this. So capital letters are the angles and small letters are the sides. So capital letters A, B, C, capital letters represent the angles and small letters represent the sides, as in A, the small letter of A opposite to the angle A represents the side A. As you can see, opposite is C, opposite of angle B is B. As also this side, opposite of angle E is side E, opposite of angle F is side F, opposite of angle D is side D. So looking at this, the rule of similarity, this is trying to say that since all corresponding angles are equal and all corresponding sides are in the same ratio, this means angle A is equal to angle E. Angle A would have to be equal to angle E. Let's build a wall right there. And angle C will have to be equal to angle F. It will have to be equal to angle F. So since CA is equal to angle E, C is actually equal to angle FD, and angle B automatically become the same thing. But now we are looking at, these are the same angles, right? So basically we are now looking at, you were looking at the angles basically here. Now you want to look at the sides. All corresponding sides are in the same ratio. So the function, the aim of these two triangles is to make this one look smaller and this one look bigger. So basically what it is trying to say is that, let's say the ratio of angle, as you can see, the sides are kind of like, let us say from A to C, it's from angle A to angle C is the same thing as angle, it's the same side from angle A to angle C is the same thing as the side from angle E to F, because angle E is right here and angle E is equals to angle A and angle F is equals to angle C. So that means this is kind of like the same side, even though they are not equal, but in relations to the angles they are kind of the same. And then from angle E to angle D, this side here, the in-between angle is also here, like this one right here. So about that, it's like from the side A to B. So basically writing this down is trying to say is that side C, which is this side here, with the ratio of side F, right, is equal to side B to the ratio of side D equals to side A with the ratio of side E. Judging by the relationships, how they are, as you can see from this angle right here, which is also the same as that angle, to this angle right here, which is the same as that angle, it is the proportions of those sides whereby the angles are the same. So basically having to pay attention to the angles. Paying attention to, therefore, paying attention to the sides in relation to the position of the angles. So the sides in relation to the positions of the angle. So this angle right here, which just has one strip, one mark, so is represents that it is equal to the angle E. So angle C, which has two stripes, is actually equals to angle F, represents that it is equal to angle F. So it has to be in that sort of relation. So paying attention to the sides in relation to the position of the angles. So let us look at an example of a similar triangle. Here's one example we are looking at. So basically what this means is the same angles plus the three pairs of sides in the same ratio could explain a similar triangles, especially if NB, important, just focusing on the three pairs of sides in the same ratio. This is the main focus. Three pairs of sides in the same ratio. So basically what happened as we were proving this theory right here, as it is right here. So basically with similarities, as it is said, all corresponding angles have to be equal. So basically this could be like angle for similarities. But anyway, looking forward to it. So it is A is equal to E. Let us build a wall, because as you can see, we just use the one line, one strike to just notify, just to show which angles are actually the same. As you can see, double line means that these two angles are the same, and triple lines means these two angles are actually the same in different triangles, because in the end the sum of the total interior angles of a triangle is equals to 180. So that's why, even though the sizes of the triangles are not the same, it is possible for the different triangles to have the same angles. So yes, to have equal angles basically. So basically looking at this again, we are okay, no problem. C is equals, sorry about that, equals to F. C is equals to if angle C is equals angle C, which is double striped, is equals to F, which is also double striped. And then angle B is equal to angle D, because angle B is triple striped and angle D is triple striped too. So we have found that. So basically what this also means, we will say that A, as we were looking at it here, the smaller ones are equals the ratio of the sides basically, which are the small capital letters. So as we have noticed, the small capital letters which show sides are actually the opposite side to the angle. So we would call this side A because it is in the opposite direction of angle A, right? Angle A to the ratio of this triangle right here, side A with E. Since E and A are equal angles, that means the opposite side of E, which we will call side E, their ratio should be equal to the ratio of B, which this is the side B, should be the ratio of B to B. It has the equal angle as D in the other triangle, so that means the opposite. So that means B, the ratio of B to D should also be equal to the ratio of the opposite of angle C, is side C, as we've also captured it here. So it is side C to the ratio of F, which F has the same angle as C. So the opposite side from angle F is F, whereas the opposite side for angle C is C. So basically these are supposed to be the same in order for it to be considered similar triangles. So basically what this means, side A is equals to 3. Looking at the other triangle, side E is equals to 6, which equals to side B right here. Well, let me just write them all in brackets to make sense. So basically this is B, this right here is C. Let's just put a hashtag to represent that it is kind of excluded. And then this is C. Hope this is not that confusing. And then here, right here, this is F. This one at the opposite side is E. And this side right here is D. Okay, so now we actually found the sides. Hope this is not confusing much, but anyway, so that means B, which is 4, to the ratio of D, which is 8, and C right here, which is 2. C, sorry about that, C is 2, is to the ratio of F. F is equals to 4. If these are all equal, therefore Simplifying this ratio, it is 1 to 2. When it comes to ratio, it's also like just dividing. It's like 3 over 6, 1 over 2. So it's just 1 to 2. It's equals to 4. Sorry about that. Looking at this again, the ratio of 4 to 8, it is 1 time, and 4 times 2 is 8. So it's 1 to 2 equals to 2 goes in once and 4 twice. So basically the ratio again is 1 to 2 as it is in fractions. So basically now this is a similar triangle. These two triangles, triangle ABC is similar to triangle EDF. Now we are looking at a different example of similarity, similar triangles. So basically, this one right here of similar triangles, include, this is two pairs of sides in the same ratio, 2 pairs. So that means just 2 sides in each triangle, plus included angles are equal. So that means the included angle has to be equal, and then the pairs of sides have to be in the same ratio, not equal but in the same ratio. So basically what this means is A is supposed to be equal to E, right? But now one thing you should also look at, since A is equal to E, we need to look at the sides from the in relation to the, we have to look at the sides in relation to the angles, to the positions of angles basically. So basically the ratio has to be like determined by the fact that looking at this side right here from A to B and then A to C, this is where the angle is in between. So basically the ratio has to be like this, considering the angle which is in between. Since A is equals to E, that means one side of A of the triangle has to be in the same ratio as the other side of the other triangle, but in relation to the angle. So you have to like pay attention to the angles, where the angles are situated at this point. Of course, 2 pairs of sides in the same ratio plus included angles are equal. So basically, so also looking at the included angles are equal, we have found the 2 pairs of sides in the same ratio. So basically what this means is let us write the sides properly. So having written the sides, the side could also be considered as AB, AC, and so on. A, D, and AF. Normally the angles are not put in like this. Normally it would just be letters at this point. I just put in the angles just for my examples because I do not have much space here. So basically, it's actually not appropriate like this, putting in the angles here at this point. So we can actually cut them off. At using these triangles, we do not put angles here, we just put in letters, and then at this point this is where we use the angles. But anyway, So basically what this means is, in relation to the angles, AB has to be in the same proportion as ED because of the angle which is found in between. The angle found in between AB and AC is equal to the angle found in ED and EF. So basically we are assuming that this is how the proportionality goes. So how we would do this is C, this means the ratio of C to the ratio of F should be equal to the ratio of, let's say A, right here, A to the ratio of E, which is equal to the ratio of C, or we have actually included, so that's the ratio of B to the ratio of D. So here we are looking at the two pairs of sides. So basically, since we have two pairs of sides, we have the side of B, this is what we want to use, and the side of C, which is what we're going to use. So we're just going to replace that only. So basically, it is C equals to B, right? Then that means C, we have found that it is, I think I'm going to need to build a wall here. So it is 4. C being the side opposite and the angle of C, right here. So it is 4. Whereas right here, F, which is the opposite of angle F, is 12, which is equal to, we are now looking for B. B, the opposite of angle B right here, is 3. That's the side. 3. And then D, we are looking for D, which is the opposite of angle D, which is 9. 9. So basically, let us put in an arrow, is equals to 4 over 12. So 4 goes in 1 time and goes into 12 3 times. So it is 1 over 3 equals to 3 goes in once and goes into 9 3 times. 1 over 3. Therefore, it is a similar, these two are triangles, triangle ABC is similar to triangle EDF. Please excuse the unneatness because we're just trying to remove these angles here, because this is based on, normally in the books it is just the letters and not the angles. The angles are included when making the sums.